A warm welcome to one and all present here. So, good morning, professors. So, I welcome you all for this Anna University sponsored online 6 days faculty development program on data structures. A welcome address and introduction session will be given by Dr. Prakash M, Professor and Head, Department of Computer Science and Engineering.
Good morning to one and all present here. It gives me a great pleasure to welcome you all for the 6 days Anna University sponsored online FTP training program on CS 8391 data structure. The main objective of this FDP is to enrich the knowledge of faculty through interaction with the eminent personalities from academics. The knowledge sharing will improve the teaching learning process to the students and benefit to the society. The online 6 days FDP on CS 8391 data structure is scheduled 4 sessions per day. We have received more than 300 plus response and selected 50 plus external participants to this FDP training program data structure. At the end of every session, there will be a photo session. In this, the entire topic which will be covering the Anna University portions and Anna University syllabus. On the day 6, we have planned for an engineering education, pedagogical issues, outcome-based education, followed by an online test. To qualify to get the Anna University FTP certificate, the 80% attendance is mandatory and the 60% mark in the online examination is mandatory. Finally, I would like to welcome all the faculty members for joining this faculty development training program on the data structure. And thank you for joining with us.
Thank you, sir. So now our first session on abstract data types and arrays will be handled by Dr. Allen Joseph, sir. So he is currently working as assistant professor in Kattam College of Engineering in Department of Computer Science and Engineering. He has a total experience of 8 years in teaching in his areas of interest are machine learning, image processing, data structures, embedded systems, process control, and computer networks. He has published more than 20 papers in national and international journals and conferences. I welcome you for this FTP, sir. The session is all yours.
Yeah. Thank you, ma'am. Thank you. Is my voice audible? Is everyone able to hear my voice? Are everyone able to hear my voice?
Yes, sir.
Yeah. Okay. Thank you. So I'm yes, yeah. Thank you. So I'm Allen Joseph. I did my PhD in College of Engineering, India, Anna University, Chennai, main campus. And right now I'm working as assistant professor in College of Engineering, in the Department of Computer Science and Engineering. So the main thing that will be focused on today is what I'll do is try to work with abstract data types, and the next thing is I'll try to work with. So this is my agenda today. So what I'll do is I'll go directly into the topics, so that you're able to have an idea of what is abstract data type and what is the meaning of arrays and how to use them. So let me just start. So I'll share my entire screen. So what we'll do is we'll just try to go on to the theory in the first half of the session, and then we'll just try to go into the practical aspect of what to do with the abstract data types and arrays. So is my screen visible to everyone? Hello. Yes, thank you. So what we'll do is we'll just try to work on abstract database. So I'll start directly with the presentation. So is my PPT visible? Can I have answers, please? Yes. Okay, thank you. Thanks a lot. So we'll just start with the presentation. So what I'll do is, if my PPT is not visible, please stop me so that I can correct myself. So I'll just start with the topic. So the topic is abstract data types and arrays. So what we'll do is we'll just try to work with this abstract data types and arrays. So the first thing is, this is my agenda. My agenda is introduction and types and what are the types of abstract database, and the last one is implementation. So what we'll do is we'll just start with the introduction first. So I think all of you know about basic data types. The basic data types are int, float, double, long, and these are all considered to be built-in data types. So what are built-in data types? So what I do is built-in like double, whatever it is. All right. So these are all built-in data types, and we'll just go on with the next one. The next one is there is something called abstract data types. What is the meaning of abstract data types? So data structures that are not built in are known as abstract data types. So this is your basic abstract data types. So what we'll do is we'll start with the name called abstract. So the abstract is like, take for example, if you want to publish a paper, be it IEEE or whatever it is, they'll ask you the abstract of your paper. So what is the main thing that you have to know is abstract means it doesn't give the underlying implementation of your work or underlying implementation of your code. So it just gives you the actual I mean, it's like a front end. It's like it just gives you the front end. It does not give you the underlying implementation of your code or whatever it is. So this is the main difference between an abstract data type and we have an ordinary data type. So kindly note that. So if you want to customize your data type, you have to use abstract data types. So if there are any doubts, kindly raise your hands. I'll just try to clarify it. So this is the data structures that are not built in are known as abstract data types. So we'll just go to the types of data types. So basically there are three abstract data types. The first one is stack, the second one is queue, and the last one is list. So this might be familiar to those who have studied stack and queue and list structures in so we'll just try to go on with the types of abstract data types. So the first thing that we'll concentrate on is stack. So we'll just start with the stack. A stack, as you all know, that is a linear dynamic data structure that follows last in, first out. So this is your last in, first out principle. And the general example, the general analogy that they give is, you have a pile of books. You have a pile of books and you arrange it on a table. And what you do is you just stack it one after another. It means that the book which is at the end, all right, will have a possibility of getting picked at the last. All right, so it means that last in will be the first out. The book on the top will be the first out. So this is your stack, and the basic example is a stack of books. So we'll just there. So these are basic operations stack. Details of it in the sense we are not going to go on with the implementation part of it. We are just trying to see what are the abstract representation of it. So the reason is called abstract data. Let's try to go on if empty or not. See, if something is full, you don't fill it more, which means that it mean? If you just fill it more, it will just overflow. The same thing happens here. So is empty means checks whether the stack is empty or not. So the next thing is size. So size is required for manipulating your stack. So the size is very important, because once you remove an item, the size will decrease. Once you insert an item, the size will increase. So these are the two options. And the top element function returns the top element of the stack. So this is your basic function. We'll just go on to the other functions which are used in almost all the stacks. So this is your next one, working of push. So this is your working of push. So working of push is like you just try to add a new element. So the new element will be added to the top of the stack. So here you can see. So I'll just try to highlight this one. All right. So what I do is I just try to highlight this one. So this is your top of the stack. So this is your top, and this is your starting element. All right. So we have a top and the starting element. So kindly note here, we have 1, 2, 3, 4, and the new element, which is nothing but 10, has been added to the top of the stack. So I'll just try to zoom it further. So let me just zoom it further. So I think it's clear to everyone. So is this clear to everyone? Just unmute your microphone and just inform me, right? So is this clear to everyone? Yeah. 1 minute. I'll just come back again. So yeah, I just need some feedback. Yeah, is it clear to everyone? Please, is the presentation okay? Yes? Clear, right? Okay, fine. Okay, thank you. So I'll just go on further. So let me just go on further. So I'll start here again. Yes? Okay, so I'll just start here again. So we just have the push here. So in the push, as I said earlier, so I'll just try to go on with the push. So we have a top of the element. All right, so this is your top, and we'll just try to zoom it. All right, so this is your top of the element. So we'll just try to add the element. So the element will be added on the top of the stack. So we have the top of the stack. So in the next one, what we'll do is we'll just go on working on pop. So pop is like something like you just remove the element X at the top of the stack, which means that you're not going to remove the element at the bottom. So what you do is you just remove this element, which is at the top of the stack. So this is going to be a 4. So when you try to remove it, so it will become 1, 2, and 3, and the size of the stack has decreased. So when you consider the stack, it's going to be 4. The size of the stack is 1, 2, 3. The size of the stack will decrease. So this is this is going to decrease by 1. So this is your working of pop. So there are other types of functions also will allow you to work with this stack. So the push and pop is the normal, which is used by everyone, and peek and is empty is null. These are the other functions which are used in programming languages, which will depict the same thing that I told earlier. So this is the basic thing. So this is about stacks. So we'll just go on with the next one. The next one in abstract data types is, so the next one is going to be your queue. So as you all know, a queue is a linear dynamic data structures that follows first in, first out principle. So first in, first out in the sense, take for example, you're going for a voting system. You're asked to cast your vote in the booths. So what do? You don't crowd there. They allow you on the basis of first in, first out. Whoever is going to come in first will get the first service. So this is the basic aspect of queue. So we'll just try to work with this queue. A queue is a linear dynamic data structure that follows first in, first out principle. So this is the basic thing. All right. So we'll just try to see what are the functions associated with queue. So these are the basic operations of a queue. The first one is empty, checks whether the queue is empty or not. It's going to check whether any data is present or not. The second one is size. Size returns the size of the queue. It just gives you the size of the queue. And the next one is front element. So there are two things in the queue. The one is called the front and the next one is called the rear. So we have the front element. The front element returns the front element of the queue if the element It is the element which will be dequeued next. Dequeued means, I'll just tell you what is a dequeued in the next slide. So we'll just try to go on with dequeued. All right. So this is your dequeue. Deletes the front element of the queue. So it means that dequeue means you're going to delete the front element of the queue. All right. So we'll just try to go on further. So this is your front element, and the next one is your rear element. Returns the rear element of the queue. It just gives the back element of the queue. It's the element behind which next element will be enqueued. So it's like, it just tells you the back rear view, and it just tells you where will the next element be added. So this is your next one. And the next one is enqueue. Enqueue means adds the new element at the backside. Rear means the backside of the queue. Consequently, the size of the queue increases by 1. So when you try to add a data, what will happen? The size will tend to increase. So this is your next one. So the next one is, like, as I said earlier, we have a front and rear. So what I'll do is I'll just try to highlight this one. We have a front and rear. So I'll just try to zoom it. So this is your front and this is your rear. So the front element and the rear element. So in DQ, 1 has been removed. So 1 has been removed, and we have 2, 3, 4. So you are deleting the front element. So this is the difference between NQ and DQ, and we'll just see some general functions which are there in NQ and DQ. So QDQ code is, but what I'll do is I'll try to code the next topic which is going to come. So the next topic for your presentation is a list. So some people work with lists. There are many types of lists. All right, like list, linked list, simple linked lists, and double many types of data type. So it's the calling list as an ordered collection of data type. So let me highlight to you the word ordered. So what is the ordered data and the next. So this is your basic representation of linked list. All right. So let's just go deep further. So what we'll do is implementation of linked list with 3 nodes. All right. So let me start the first one. So this is your first one. So you have a head here. The head will point to the first node, and then you have a second node, and this is your third node. And when you're going to complete your data, meaning that when you're going to fill in your data, it means that the last node will point to null. Null means nothing. So this is the basic thing that you have to know. So there are 3 things that you have to know. There is a head, there is a null, and you have a data and next combined. So this is your
Alan sir.
one.
Alan sir.
This is your 1, this is your 2, and this is your 3. So these are the basic things. All right. So this is your link.
Sir,
Some of you
sorry
may
for the
know
interruption. Your voice
what
is
I do.
breaking. Respected faculties, sorry for the interruption. Chief guest will join soon and he'll continue the session.
Ma'am, right now is it okay, ma'am?
Yeah, yes, sir. You can continue, sir.
Yes, ma'am. Thank you. So is my screen visible to everyone?
Yes, sir.
Now, yeah, okay, thank you. So I'll just start with the linked list again. So I will try to go here. So I think I'll start with the code. All right. So this is your node structure. All right. So this is how you declare your node. All right. So this is your struct node, and in data struct node star next element. So this is your pointer. So what I will do is I'll just try to go on with the pointers, and then I'll uh, uh, try to demonstrate this linked list. All right, so we'll just go on with the next one. So we'll start with the presentation. We'll start the code right now. So what I'll do is I'll just directly start. So for a demo today, I'm just using Dev C++, so which will allow you to work with linked list and other data types. All right, so we'll just start with the first one. So I think my screen is visible to everyone. If not, kindly raise your hands or can just inform me. So let me just start. So before starting with linked list, what I will do is I'll just try to go on with pointers. So most of you know about pointers, but without knowing pointers, you can't proceed further in most of the data structure works. All right, so we'll just try to work with pointers. So before that, I'll just try to give you an overview of what is a pointer, and then we'll just try to manipulate the linked list. All right, so let's just start with the basic demo of pointer. So I'll open a board. All right, so this is your basic demonstration. So let me just start. All right. So there are certain things that you have to know with respect to pointers. So the first one is people will tell you that you have to have a pointer for efficient working, which means that you can have dynamic memory allocation with the help of a pointer. So for our reference, what I'm going to do is I'm going to draw two boxes, right? So I'm going to draw two boxes. The first one is like, let this be the pointer. So we have the pointer variable PTR, and the next one is going to be your actual variable. So let this be your normal variable A. So let this be of type int. So what I'm going to do is I'm going to assign a value here, A. So remember, this is an abstract way of representing what is actually happening in the memory cells. All right. So we have a pointer here, and let me just give an address of 0x. So x represents hexadecimal. So we'll just try to manipulate this 3000. So we'll just try to manipulate this address, and let this address be 0x. So let this address be 2000. So we just have this as a representation. All right. So what we're going to do is we're going to see how a pointer works right now. So we'll just take this address and give it to a pointer 0x3000. So this is your pointer. So this is the normal representation, which many of you might know. So you have a representation like this. So here we have two variables. One is the normal variable called A, and the next one is called the pointer variable. So as you all know, pointer holds the address of the variable. So this is your basic representation. So please keep this in mind. I'm going to write a code based upon this representation. All right. So let me just write it. The basic code. So I'm going to include the tag IO files and IO.hash. So the next one is we'll just try to include the next aspect of the pointer. So then we'll just use a main. So I'm going to write an int main. So you can write void main, but Dev C++ does not support more void. So we'll just go on with int. And then this is how we declare a pointer. All right. So we'll just try to work with the data. So this is your A equivalent to 10. I'm assigning 10 to A. And in the next step, what I'm going to do is I'm trying to take the address of A. So which is like I use an ampersand A here and give it to pointer. So this is your pointer. So this is your pointer. So you've taken the address of A and you're giving it a pointer. All right. So we'll just try to print the data now. So I'll print the data with the help of a escape sequence, print/n, and the next one is I'm going to type the value of A. This is your value of A. So we have a value of A, and since it is a integer, I'll use a %d format. Where D stands for decimal, and then what I'll do is just type A here, and in the next printf. So let me just go on a printf, and what I'll do is just go on further. The value of PTR. So this is your PTR. So what I'm going to do is, since PTR is always a integer data type, so I'll just try to work with this one. So PTR, and I have used readable operator called star and write it as PTR. So this is your PTR. So we'll just try to work with this one. And in the next step, what we'll do is we'll just try to go on with the address of PTR. So we'll just try to print the address of PTR right here. So this is your last one, printf. So we'll use the escape sequence and the address of, so we'll type as PTR. So this is your address of PTR. So what we'll do is I can use %e for this or %u depending upon your requirement. So I'm not going to give any operator in front of PTR. So I'm just typing PTR, and this is the one. All right. So let's just use one more representation also for a reference. Let's check whether it is working or not. So we'll just try to manipulate it as printf address of A. So we'll just check for the address of A. So let's try to compile this code. So we'll just try to compile this one. So it's asking for saving the code. So we'll just save this one. So it's getting compiled. So that's a common thing that you have to find here. So our students, sorry. Yeah. So this is the main thing that I wanted to show. See, just yeah. Let me magnify my screen. So I'll try to magnify my screen. So this is your data. All right. The value of A is 10. The value of PTR. So the PTR, I didn't give any referencing. So let me just go on. So the thing that I wanted you to notice, the address of PTR and the address of A are one and the same. All right. So there is no change in the address. So this is what I wanted to show. So I'll just try to minimize this. Yeah. And I'll just try to go on further. So I haven't given any data. So this is your PTR, PTR star PTR. Yes. I've left a percentage D here. So let me just try to run it again, execute it, compile it. So I'll just try to run the program again. So let me just try to display the result. So remember, we have 4 results here. The value of A is 10, the value of P is PTR, the value of PTR is 100, and the address of PTR and A are one and the same. So this is the pointer bus. All right. So what I will say is try to go on with the linked list. All right. So I just wanted you to be familiar with the pointers. So let me just go on with linked list. All right, which uses pointers as one of its aspects. So let me just go on. So I'll just try to start the basic include file. This is our include file. So write it as standard input output.h. And in the next step, what we'll do is we'll include this library files. So this is your hash include. So this is your hash include standard lib.h. So this is your lib.h. So in the next step, we'll start with a node. So this is your structure node, HDREC. So this is your struct. Struct is the keyword, and we're going to give tag for it. The tag is node. So this is your tag, and we'll just try to type in our data in between. So right. So as you all know, structure is a collection of different data types. All right. So we'll just try to manipulate this further. Int data. So this is the first thing. All right. So in the next thing, what we'll do is we'll just try struct. So we'll let's struct node. So I'm going to introduce a new aspect here, star. So as you all know, as I said earlier, star stands for pointer. All right. So we have a pointer here. So this is your next. All right. So I'm going to close this one. I'll go on to the next one. Let me just start. So the main code. So int main. So this is our first thing. We'll just try to work with this one. And I'm going to create three. It means that as I showed in the picture earlier, I'm going to create three elements. So for that, I'm going to start with the first one. So struct. So this is your struct. And node. So we have a node here. And the next one is, we're going to have it as a head. So we have a head here. So initially what I'll do is I'll make everything a null. So we just have null here. All right. So we have a null here. And the next one is we have a struct null, head null. And we have a second. This is a second. So we have a second here. So this is also going to point to null. And the next one is third. So this is your third. This is also going to point to null. So we have these different ones, 1, 2, 3. So we have to allocate some memory to it. So what I'll do is I use MLLock, so which is like a dynamic memory allocation in pointers. So this is your struct. So we have a struct here and node star. And the next one, I'm going to use MLLock. So this one will be equivalent to size of. So I'm going to use the size of operator here. So this is a function. Size of, what I'll do is I'll just try to take struct. And since we have 2 here, I'll take the struct node. So this is your struct node. We have a struct node here. So we'll just try to manipulate this further. All right. So let's just go on further. So we'll just copy it so that we can manipulate it further. So this is a head, and the next one is going to be a second. We have a second here, and the next one is going to be a third. All right. So we'll just try to work with third. So this is a third. So I'll tell you what I'm basically doing. So let me just tell you what is actually happening here. So I'm trying to implement this one. All right. So what I'm going to do is I'm trying to implement this one wherein you have 1, 2, 3. Okay, 3 spaces for elements, and we have a pointer to the next data. All right. So this is what I'm trying to implement. So we have a head here, and the last element will point to null. So what we'll do is we'll just try to code this further. All right. So we have head, second, and third. Then afterwards, what we do is we are done with this one. All right. So we'll just try to assign some elements to the data. So we'll try to go on with the first one. So the first one is head. So we'll use a operator like this now. So we'll just try to, yeah. So we have a data here. So it's autofilling. So we have head data equivalent to 1. So instead of 1, we'll make it as 10. So we close this one, and the next one is head. So I'll use this arrow operator. It mostly comes along with structures. So here I'll use the node next. All right. So the next is going to be, in our case, the next is going to be second. All right. This is a second, and we'll just try to go on to the next one. All right. So we have a head here, data, and head next second. So we'll just try to manipulate the second one. Second. So this is your second, and we'll have a data here. So let this data be 45. We'll close this one. We'll close this one also. And the next one is we'll have a second. We'll have a second list. All right. So we'll point it to the next one. So this is going to be pointing to third. So this is your third. So we have done with 2. The last one is we have a third. So third, we have a third here. The third here is going to be, we have a data here. So data is going to be equivalent to 25. So I'm assigning some arbitrary values to it. So let me just go on. So third. So this is a third. And finally, we'll just point it to the next one. Since we don't have any data further, we'll go on with null. So this is our null. All right. So we are almost done, but we have one thing to do. The last thing is we have to print. All right. So we'll try to print the data. So I'm going to print the data, print list. So this is my list, print list, and I'm going to print the head. Remember, you can access all the elements if you know where the head is. All right. In a linked list, you can access all the elements if you know where the head is. So I've created a function called print list. So what I'll do is I'll just try to work with this print list for the time being. So I'm going to return 0 to make sure that nothing is being given out of the function. So let me try to include print list on the top. So this is your print list. So I'll type it as int. So this is the print list. This type as struct. So this is a node, and the next one is going to be small n. All right, so we'll write a function. So this is your function. So while, so this is our while again not equivalent to n not equivalent to null. So which means that as long as the next does not encounter null, you have to execute this function. We'll save the program. So ADT So I'll just try to go on with the thing we saw earlier. So this is your final implementation of I think I have to share my screen. So this is your final implementation. So this is your basic presentation. So what you do is you just go on the next one. All right. So this is your implementation. This abstract data types initialize, get, insert, remove. All right. So this is your abstract data types. So we'll just try to go on further. All right. So the next thing for our discussion today is arrays. All right. So this is the last. So we have array. The next one is your 3D array. So these are the three types of arrays that you have to see. So I'll start with the first one. All right. Let me just start with the first one. The first one is we have a 1D array. So as you all know, so this starts with 0. The first index is 0, 1, 2, 3, 4, 5, 7, 8, and we have a 9 here, and the array length is 10. All right. So this is your array length. So array length is 10, and the last one is element at index 8. So element at index 8 is like you take the 9th element. So this is how your 1D array works. So let's just try to work this one out. All right. So we'll just try to start to code this one. All right. So we'll try to code the program. So let me just start. So we have this basic function. I'm going to use just a single function, stdio.h. So this is a basic one. So in the next one, what I'm going to do is I'm going to write a program for having one-dimensional array. So this is your program, int main. So I'm going to have a main here. Let me just go on with the next one. So we have a main here. So this is your main, and I'm going to create a float data type. So this is your float, and I'll put it as RI. So this is my float. So I'm not going to conclude my code. This line, I'm not going to conclude float right now. So let me just go on. So I'll try to go on with this one. Printf. This is my printf. So I'll ask the user to enter the array elements, enter the array elements. So we have an array element. All right. So we'll make sure that Ri holds an array. So what I'll do is I'm going to declare a size of 5. So the array size is going to be 5. So we'll just try to go on further. So I've asked printf enter the array element. So in the next step, what we're going to do is we'll try to go on. All right. So introduce a semicolon here. So in the next step, what I'll do is I'll just try to code this one. For, so I have a single scanf. So I'm going to use a for loop. For, so this is your for I equals 10. I less than, this is your I less than, so we don't need a 10. So we'll just make sure that I equal to 0. So this is your I equal to 0, I less than 5, and we make sure that we are getting the data in a better way. So this is your I plus plus. Okay, so this is your I plus plus. So this is your I plus plus. All right. So we'll just try to go on further. So we'll use a scanf here. So the scanf is going to get decimal points. So we'll try to use percentage F, and we'll try to get the data inside the array. So I'm going to use array. This is my array of I. So I haven't completed this one. So what I'll do is I'll just try to use an int here, int, and I'm going to use the I here. So we'll just try to go on with this one. All right, using this one. So in the next step, we have a scanf %f I. So after that, what we are going to do is we are going to use printf. So printf is like I'm going to print it directly. So this is your printf. All right. So this is your printf. So we'll just try to print the value of Ri. Value of Ri. So this is a Ri. So what I'm going to do, since it is a floating point representation, so I'm going to use percentage 3.2f, which means that I have two decimal points and 3 digits. All right. So this is my 3.2f and comma. So I'll use Ri of. All right. So this is the basic thing. So we have created a simple arrays for our purpose. So we'll try to introduce a return here, which means that the function is not going to return anything. This is your return 0. All right. So we have return 0 here. And we are done with this one. So let's just try to work with this one. So let's try to save this before running this program. So let's just use P45, save. So we'll try to compile this one, execute compile. So it has compiled. We'll just try to run the program. So enter the array elements. It's asking for entering the elements. So I gave you 5 elements. So before that, I'll try to tweak this program further. Enter the array elements. So enter 5 elements. All right. So I'm just giving enter 5 elements. We'll just save this one and let me just compile this one and run this one. So I'm going to use 5 elements here. So I'm going to read 34, 44, 46, 78, 78, 77. Okay, 78 and 1, 2, 3, 99. 90. Okay, so this is your 99. So the next thing is I'll introduce decimal point here, 0.33, 0.45, 0.90, next one is 0.3. So let's try to run the program, and it's not displaying anything, so it's like it's shooting out an error, which means that I'm missing something. So what is this like? Let me just use a normal value of I. So use a new line here. So array of 5, yes. Yeah, I'm making a mistake here. All right, so this is the problem. So please be careful with semicolons. So we'll just try to compile this and we'll just try to run this one. All right. Right. So 3.1, 4.2, 4.5, 5.6, and 8.9. This is your data. All right. So I'm obtained my data, so I'll just try to be precise, more precise. So what I'll do is I'll just use percentage 3.2f. So I'll try to compile this further because I need only limited spaces. So let me just run the program. 2.3, 2.5, 6.7, 8, 8.9, and 7.0. So what I'll do is I'll try to enter this and I'll try to magnify the screen. So this is your data. All right. So this is your data. So we have this 2 decimal points for the value of array. So this is a single dimensional array. So there are other two types of array. So I'll tell you what the basic working of other two types of array. So you have to know that your 2D images, basically your 2D images, which is like a photographic images, is like when you use a black and white, it just has two dimensions. Two dimensions in the sense it has. So it has just the x-axis and y-axis. So remember, you studied in your classes like you would have studied in your classes like your matrices starts with 0, 0 or 1, Aij. So you have a Aij represented by 0, 1, 2, and J also represented by 0, 1, 2. So these are your 2D arrays. All right. So I'll try to implement this alone for the time being, and I'll give you an idea of what is a 3-dimensional array. So this is your single array. So we'll just try to go on with 2-dimensional array. So if you want to work with 2-dimensional array, you have to have another for. This is your for j equals. So we have a j equals. This is your j equals 0. Just j equal to 0, j less than 2. So I'm going to use a 2 cross 2 matrix right now. So here also I'll just use less than 2. And in the next one, what I'll do is I'll increment j plus plus. So for a representation, I'm going to use int right now. Int r of I, comma, I, comma. So this is your data. So we'll just try to manipulate this further. All right. Enter the elements, enter the 5 elements of 5. Enter the elements. All right. So we'll just try to elements of the array. This is your enter the elements of the array. So we have this representation ij. So we'll just try to go on further. So we'll just try to manipulate this. We'll have a scanf here. The scanf is this one. So scanf percentage f. All right. So this is like ri of I and j. So we are having 2 elements, and it's going to be decimal point b. And here we have to change the dimensions as 2 cross 2. So this is your 2 cross 2. All right. We have a 2 cross 2 here. And enter the element of the array. Scanf. Yeah, we're done with this one. And what we do is just try to use another set for printf. This is your scanf, and we'll just try to use another set for printf. Printf percentage d. So we make sure we are getting the data. Percentage d, ri, l, containing the ing to l and m, because if you're giving ing as such, it will override the existing data. So we'll just try to type this l and m. L. Yeah, this is your last one. L and M. We're done with this one. We'll just try to compile the program. So we'll try to compile it. So it's showing undeclared function. So I think I'm missing something. IJ, everything is there, and I'm missing L and M. Okay. It's asking expected a token. Yes, I'm using a comma here. So this is your semicolon here. So we'll just try to compile this one. It's asking expected. Yeah. Something else is missing. Yeah, this also. Yeah, now it's compiled. So we'll just try to run this one. So I'm going to enter random values. 2, 4, 5, 2 cross 2, right? So I'm just enter two elements and I'm getting the results also. So the thing is, I'll just try to introduce a new line here so that the result is very visible. So we'll save this one, execute and compile. Run. All right. So 45, 12, 2 cross 2. So we have 4 values, 23 and 46. So our results has been displayed, which means that we have scanned the data for a 2-dimensional matrix and we have acquired it. So the last thing is a 3-dimensional array. I'll tell you what it is. I won't type any code for this one. The thing is, you just have to increase a for loop. It means that you have to use a k for incrementing your for loop. So the thing to be noted is it is mainly used in image processing. So the thing is like it's used in image processing for having 3 different pixels, which means that R, G, and B. It means that red, green, and blue. All right. So the pixels may be of 8 bits. 8 bits in the sense you have possibility of 2, 0, or 1. So 2 to the power of 8, it will range from 0 to 255. All right. So this is the basic thing about 3-dimensional arrays. It is used in today's world also in convolutional neural networks and TensorFlow. TensorFlow, all these are used for image processing. All right. So we'll just conclude our topic today. So this is the last thing. Types of abstract data types and how to use them in real world. So this is the thing that we saw. And the last thing that we saw is working with arrays. All right. So if you have any questions, you can just ask. All right. So I'll just wait for your questions. Yeah, if you have any questions, you can kindly ask. Regarding what was taught today, if you have any questions. Okay, I assume that you have understood all the topics. So let me just try to give you like what actually happens here. So remember, you have an array, right? So I'll just try to give you a basic idea. So what I'll do is I'll just open a simple software which will allow you to understand the basic 3-dimensional arrays, which is used in today's world. So let me just start. So this is familiar to most of you. We have a paint here. All right. So we have a paint here. This is like, we'll just try to open this app. So what I'll do is I'll just try to open a add color. So is my did I stop? Yeah, 1 minute. So I'll just try to share my screen. All right. So this is the basic thing which happens in image processing in today's world. All right. So the thing is you have a paint here. And as you can see, there are 3 primary colors here. So this is your 3 primary colors. So I'll try to magnify my screen. So there are 3 primary colors here. So as you all can see this in any image processing software. All right. So this is your 3 colors. The 3 colors are red, green, and blue. All right. So the values ranges from 0 to 255. So you can change the values to, even if you're going to change it as 278, it won't change. It just go to 255. All right. So the lower value, if you're trying to give it as -1, so it will not change. All right. So this is like the same thing that will happen. All right. So this is 0 to 255. So it is a color combination, red, green, and blue. All right. So this is like mostly used in image processing techniques for image enhancement. All right. You can use fuzzy or whatever it is. You can just try to manipulate this with the help of RGB. So yeah, if you have doubts, you can ask, or else and start. Ma'am?
Thank you so much, sir. So, professors, if you have any doubts,
Okay,
you can ask Aaron, sir. Sir, I hope they don't have any doubts. Thank you so much for the session, sir. So I
Thank you,
request
ma'am.
all
Thank you.
participants to, thank you, sir. I request all participants to switch on your camera so that I can have a photo session. Sir,
Yeah, ma'am, one
Alan,
person.
sir. Yeah,
Yes, ma'am.
one person has a doubt, sir.
Yes, sure. Yeah, Jyoti. Ma'am, I'm unable to hear, ma'am.
Professor Jyotimani. Actually, they didn't ask any questions, sir. Maybe
Yeah.
they
Okay,
forgot
ma'am.
to
Okay.
remove. Okay.
Okay.
Yeah, okay, sir. Professors, kindly switch on your
Thank you.
camera so that I can have a photo session. Sir, Aaron, sir, you two stay on the
Yes, ma'am.
call, sir. So I'll have a photo
Yes,
session.
ma'am. Sure. Sure.
Professors, I repeat, kindly switch on your cameras for photo session. Thank you so much, professors. You can switch off your videos now and kindly fill the feedback form which has been circulated in the message chat window for your attendance. Thank you, sir. Thank you, professors. You can join by 10:45 for the next session.